Hello, my name is Dylan Radulski, and this is Physics 2211, Lab 4, Oscillations. Introduction. The purpose of this lab was to analyze the movement of a weight on the end of a spring as it oscillated. We then had to create a model to predict the movement of the weight. The fundamental physical principles used are the position update formula, the velocity update formula, and the energy principle. Here are the results. I calculated the spring constant to be 6.872 and the relaxed length to be 0.126. 1. The image on the top right shows the tracker application's analysis of the motion of the mass. You can see that it oscillates in both the x and y direction. The image on the top left is simulated mass and spring, which shows the same oscillating motion. The image on the bottom shows the simulated energy principle, and you can see the energy oscillating between potential gravity and spring energy and the kinetic energy, which is to be expected due to the movement of the mass. For the lab setup, we were first given a video to use the tracker application to analyze the movement of a mass on the end of a spring. We copied the data from the tracker application into a CSV file, which we then inserted into our glow script code. After calculating the spring constant and the resting length of the spring, we were able to output the simulated mass and spring, and shown again below. We then had to compare the motion of both the predicted and actual mass and spring. Here's the important code. You can see the calculated spring constant, the relaxed length of the spring. You can see the initial setup for the energy constant. Here's the while loop that sets up the energy constant with the energy constant values, and the initial for the change in energy constant. Here's the update for every loop. And here is more of the loop to determine whenever the ball is done. Possible sources of error. The spring constant and relaxed length of the spring could have been much more accurate with more decimal places, and so the tracker application could have had slightly misjudged the location of the mass at each timestamp. What does it mean? For your model system, is the energy principle satisfied? Justify your answer by briefly discussing your plots of energy changes. I believe the energy principle is satisfied because if I go back to this slide here, you can see that all the delta K, delta gravity, and delta spring all roughly equal the delta energy total, which means that the energy constant was satisfied. Using the data you obtained in Tracker, make two separate estimations of oscillations period. First, by estimating the period of oscillation from the X position data, and second, by estimating the period of oscillation by the Y position data. Again, we can go back to the code here. You can see that one period took roughly 2 seconds, or 1.5 seconds, and for the X value, it took roughly also 1.5 seconds. This makes sense since the spring is just going back and forth and up and down roughly the same distance in basically a square. And that is all for Lab 4.